Yeah, I mean it's pretty tough to teach from school, just because the computers that we have access to are like they're not very good computers. So you need a little bit of horsepower and you need bandwidth. There's definitely a lot of good bandwidth. Like it's a very strong internet connection, but the actual computer that you use at school is like they're usually just intended for like taking attendance. You know, they're not strong computers. So I spent pretty much most of last week bugging the IT guy. His name is Dimitri, and he really helped me out quite a bit. But yeah, it didn't really pan out super well. He even like found like a video card for me, and he got me like a like one of the stronger computers that they have at school, and even so, it was not enough. So yeah, did you pick up that book, The Music of the Primes? Awesome, that's great. So are you kind of like in research mode right now, or are you writing stuff, or where are you at? Wow, that's pretty neat. I've never heard of hyperuniformity. That sounds pretty cool. Okay. Mm-hmm. Hmm. That's pretty neat. Yeah, I like that. Yeah, I remember when I took cryptography in university. uh, One of the ideas of randomness, which I kind of felt really counterintuitive, but um, like one of the topics that we talked about was being able to like recognize random strings of zeros and ones, and I guess one of the things is that like if if the last number that you saw was a one, for example, then you could expect, if it was truly random, that, and this is what I found counterintuitive, and I still don't truly like, in my heart I still don't understand it. um, but the idea was that if the last number that you saw in a string of random digits was 1, then there would be a higher probability that the next number would be 0. That you would, I know it still doesn't really make sense to me, but that's what we covered, because the idea is that if it truly is random, then you should have like 50% of your characters to be 0, and 50% of them should be 1. Um, they are independent of each other, yeah. But the idea is that, like in the grand scheme of things, you should have approximately 50% of them to be 0 and 50% of them to be 1. Um, I don't know. I don't know. Yeah, I don't know. Because yeah, I mean, one of the things about random numbers is that you wouldn't expect to see a string of like 10 zeros in a row. Like that would be unusual. Like you can kind of imagine, like if you like look at a television screen and it's the static, you know what I mean, like the um, and then you can kind of imagine that it would be weird if like all of a sudden you saw like a big block of white or something, or a big block of black. It's supposed to just kind of be totally random numbers with that static, right? So to see like a long string of zeros and one, or a long string of zeros, is kind of the equivalent of seeing like a big block of white in that staticky screen. So yeah, randomness is a really truly difficult thing to study and to understand, because it kind of like things like like on a quantum scale, things are truly random, but in kind of like the classical physics that we live in, like nothing is random, you know. So it's like we both live in like a completely random and then completely not random world at the same time. So I think that the world that we perceive as random and or sorry is not random, but then we kind of have this intuitive idea of randomness that like, oh, that thing that my friend said was so random. And I think that we kind of associate randomness with like something being arbitrary or ambiguous. So yeah, exactly. Yeah, yeah. 7 is the most random number in the between 1 and 10. Yeah. Too much in the middle. It can't be random. Yeah, 5 is not a random number. Um, how are you doing, Diana? How's your research going? Do you have sources? I think last time we were talking about game theory. Were you able to track down any sources, or do you kind of have like, have you narrowed it down? I think you were looking at, what was it, the Kingsman problem? Oh, that's no problem. Yeah, but if you need some like any kind of resources or any help, yeah, don't hesitate to reach out. Um, there you go. Yeah, that's perfectly in line with what we're talking about. That's awesome. Um, so how do you write a computer program that makes random numbers? Is that possible? Yeah. Mm-hmm. Mm-hmm. Yeah. Do you know the idea of pseudo randomness? Have you heard of that? Mm-hmm. Yeah, so that's kind of what you're describing, like how it's randomness based on the time and things like. I think that some computer programs, when they generate random numbers, yeah, they'll take time as part of the input. Some more advanced ones will take like your CPU clock and incorporate that as a random, I guess, injector, or however you want to call it, a random input. Um, because like two people could press the button at the same time, and if it's just based on time, then they would get the same. Like, it makes it predictable. But at least when it comes to the CPU clock, maybe somebody has like a different program running or something. Maybe their CPU is doing something different. I've also heard of pseudo random programs that use your microphone, and it'll take just a little recording of the sounds, or the lack of sound, or the static in the background, and use that as input. Um, there's a lot of interesting computer programs out there that generate pseudo random numbers, which is, I think, a pretty interesting topic, because it is important to be able to generate random numbers, especially in cryptography and in those fields where security is dependent on getting a number that nobody else has, and is not predictable. So pretty big topic. Um, but otherwise, pardon me. So is that third player like predetermined? or can any one of those three players be the Kingsman? Hmm. That's interesting. Who he's gonna take down with him. That's cool. So would you be able to um, describe a game where that situation can happen? Hmm. That's awesome. Um, yeah, I'm looking forward to learning about that because, like I said, I don't know a lot about game theory. Hmm. Hmm. Yeah. What is the name of that game? Or is it just a game where you're trying to lose your cards and you're just using that as an example? Drak. That's great. Okay. That's awesome. That's great. Okay, well, I'm gonna sign out then. Sounds like you guys are in good shape, and so I think that we have 2 weeks now, right? So we're gonna aim for the 12th. So I go ahead. That sounds good. Yeah. I mean, just make it as long as you think you want it to be, right? So, like if it's like 6 minutes long, and you've said what you want to say, don't feel like you need to fill in an extra 2 minutes. If it's like 15 minutes long, and you've already kind of pared it down, like don't try to cut out information that you think is interesting. Just make it as long as it needs to be, and just try to make it interesting throughout. Um, that's something that I always struggled with in university, is that I tend to be a very concise writer. I don't like to kind of go on and on and on. My sentences are usually very short, and I always struggled to meet like the page requirements for papers in university. But I always felt like my papers were very dense. Like I know how to put a lot of information into a paragraph, and I always felt like it was kind of unfair. Like shouldn't it be about content and not the number of times you press a button on your keyboard? So now that I get to sort of mark these things, I think that like the length and that sort of thing is not that important. I mean, obviously, if it's like a 1 minute or 2 minute video, you probably aren't able to express yourself fully in that amount of time. And if it's like half an hour, you're probably like just rambling, right? So certainly there's a range, but I think that like that's not the goal. I think that the goal is just to find something mathematically interesting to you and express it in the way that you think is best. So and that goes with a paper as well. If you wanted to do a write-up, Diana, I'm not sure what you're planning on doing for the format. I think maybe you told me last time, but I've forgotten. But you're writing? Okay, yeah, and in that case, yeah, if you write it in like 2 or 3 pages, that's fine. If you write it in 20 pages, I'd be a little annoyed to have to read 20 pages of work for all of my students, but I could still do it, you know. But I think the important thing is just make sure that it's interesting for the entire thing, right? I would much rather see a piece of work that's just interesting from all the way from the very beginning to the very end. And then rather than trying to fit it all into a certain number of words or something like that. So. Oh yeah, which forum? Like our chat? Oh, we got a lot of zeros in a row there. I don't know how random that is. Yeah. I mean, who's to say what randomness really is? I mean, I think that in order to talk about randomness, it does have to be well defined, right? And I think that, yeah, I mean, I certainly haven't given us a definition of what randomness really is. But yeah, definitely really good conversation today about randomness. I think that's pretty interesting because yeah, like I always kind of just figured that anything that was like that you didn't predict is random, but I mean that would mean that like the number that I'm thinking in my head is random, but that's just 7, right? So yeah, I think yeah, I'm really interested to see what are you gonna write about your program in your write up, Diana, or is this just kind of a side project? Oh, I see. Yeah, that looks pretty pseudo random to me. That's cool. Okay, I'm gonna go, and so I'll log in again on Thursday, and I'm gonna send some emails to some of the other folks who weren't here today, just check up on them, and yeah, so I'll talk to you guys on Thursday. Bye bye.